All right, in section 8.1, we're going to be practicing the geometric mean and then also the Pythagorean theorem. So in problems 1 through 9, we need to solve for x in each figure. So we're really looking at, if we need to go back and reference, we're looking at the 8.1 notes, and we're trying to determine if this is an altitude geometric mean problem or a leg geometric mean problem. All right, so if we take a look at number 1, whoops, there we go. If we look at number 1, you can see the altitude is given to us, so that's our geometric mean, and then we use this part and this part. And so here we have our setup. Remember, our mean is there, and then there are our parts, and we cross multiply and divide and get 18. Number 2 is also an altitude problem, and so there's our altitude x on the means, and then the two parts 8 and 10 on the extremes, and we cross multiply and we go to square root. We can see that we have at the square root of 80 that we then have to simplify by using that perfect square factor of 16 to get 4 square root 5. Number 3 is a leg problem, and so 9 is a leg of this larger triangle, and so you can see it goes there in the mean, and then we have 5, and then remember the other part is the whole part, which is x, and we just cross multiply and divide, and we get 81 over 5. For the next 3, 4, 5, and 6, number 4 is an altitude problem, and so that is my mean right there in red. And then I know that I need the parts. I was given that this was 15 and this was 20, so I can figure out that that is 5, and so then I use the 5 and the 15. And I cross multiply. When I need to square root here, I end up having the square root is 75, which is 25 times 3, which gives me that x is equal to 5 times the square root of 3. Looking at number 5, number 5 is a leg problem, and so there is our mean in red. And then if it's a leg problem, remember that it is this part to this whole thing. So if I was given that this was 13, that goes there. And then if this is 13 and this is 7, then the whole thing is 20, and that's how I knew that there. And then it's the same steps all the time. I'm going to cross multiply, then I need to square root, then I need to figure out what perfect square is a factor so that I can simplify it into its lowest terms. So 260 is 4 times 65, which ends up being 2 times the square root of 65. Number 6, we have an altitude problem, and so there's the x's there. And when it's an altitude problem, I need the two parts. I was given this was 6, so that goes there. If this is 14, then that means this is 8, and so that's how I got the 8 to go there. When I cross multiply, I end up taking the square root of 48, which is 16 times 3, which gives me that x is equal to 4 times the square root of 3. All right, in 7, 8, and 9, number 7, we can see that this is a leg problem, and so there's my x and x there for the mean, and then I have this part is 9, that goes here, and then I need this whole part, and I'm told this is 11, so that makes this a 20. That gives me x squared equals 180, and I'm going to have that x is equal to the square root of 180. 180 is 36 times 5, which gives us that x is equal to 6 times the square root of 5. Number 8 is a leg problem, so there's my mean at 6, and then there's my part, x, and then I'm given this whole, which is 12. Cross multiply and divide, we get x equals 30. If we look at number 9 is a leg problem, and there's my mean, and so this is x, that goes there. This whole thing is 24, that goes there. And we cross multiply and divide, and we reduce, and we get 25 over 6. In the next set of problems here, we're looking to determine, is this right, acute, or obtuse? And then if it is a right triangle, is it a Pythagorean triple? Okay, so what I did in all these problems is that in red, I circled the largest side, which would be the hypotenuse, and then I squared it, and then what I did was the other two remaining sides, I squared those and added them together. So you can see that in number 10, that result is the same as the hypotenuse, and so therefore this is a right triangle. It is not a Pythagorean triple though, because we have radicals as our sides, and a Pythagorean triple is a right triangle, but our sides have to be whole numbers. In number 11, this was our largest side, and when I squared it, that would give me 50. And then I squared the other two remaining sides and added them together. Notice I get 51. And since 51 is greater than 50, then this is an acute triangle. If we look at number 12, 18 was the largest side, so I squared it. Then I squared the other two sides, added those together, and I got 208. And since this was larger than this, then this triangle is obtuse. And then number 13, the last one on this side of the paper, 75, I squared that first. Then I squared the other two remaining, and you could see when I add those together, I got the same as the number squared here. And so then yes, this is a right triangle. And if I look at it, 75, 72, and 21 are all whole numbers, so yes, this is a Pythagorean triple.